Let's go ahead and take a look at section 2.2. We're going to split this up into two parts. So this is 2.2a, which is characteristics of quadratic functions. To start off with, let's take a look. First vocabulary term we have is axis of symmetry. And that is a line that divides the parabola in half and creates a mirror image on both sides. Remember, a parabola is symmetric, and the axis of symmetry will go directly through the middle of the parabola, or it goes through the vertex, which we've been talking about in section 2.1. Now, we have right here next up the standard form. Now, in 2.1, the way this equation was set up was f of x is equal to a and then times parentheses x minus h quantity squared plus k. So that was vertex form. Right here, I show you what standard form is. And it's f of x, or you've seen it as y, is equal to ax squared plus bx plus c. So remember, you use that when you were trying to solve a problem using the quadratic formula. Remember, you need to know what a, b, and c is. So hopefully you remember, based off of that equation, what standard form of a quadratic looks like. The main thing that you need to remember is that a quadratic function has x squared in it, and an x, or the squared, is the highest power. So if it's just x, then that's linear. X squared means it is a quadratic. Next up, let's take a look right here at what a minimum function and maximum, or minimum and maximum value is. If we were to look at a function right here, we have the minimum value is going to be occurring in a parabola that is facing upwards, right? And so this would be our minimum. And then if the parabola is downward facing, like so, then we have ourselves the max value. And they may ask for the values of x, or they may actually ask for the actual point itself, depending on the problem. That is how the problem is formatted. We'll take a look at intercept form in day 2. But just to put things down, it is f of x is equal to a, and then we have parentheses x minus p, parentheses x minus q. But we'll go into more detail of intercept form in 2.2b. All right. So properties of a parabola. A lot of these things we've actually mentioned and talked about already. When it's in standard form, one of the first things that should stand out to you is the c value. Okay, that should automatically tell you something about the graph. That right there is your y-intercept. Okay, so make sure that that value c is your y-intercept. If there's no value there, it's just like 5x squared plus 3, then it's, plus like 3x, then your y-intercept is 0. If you think about your parent function, it's y is equal to x squared. There is no c value, and the parent function happens to be at the vertex, or at the origin, which is 0, 0. They talk about right here, if your a value is greater than 0, okay, what exactly is happening? Your parabola is opening upwards, right? So pretty much it's saying that if a value is greater than 0, or it's positive, okay, then the parabola opens up. If the a value is negative number, then it's going to be going downwards. the graph is narrower at the second bullet than the graph of f of x is equal to x squared when the absolute value of a is greater than 1. And it's wider when the absolute value of a is less than 1. Think about this. We've mentioned vertical stretch and shrink. Okay, so in vertical stretch, that's when our a value is greater than 1, right? When it's a vertical shrink, that's when the a value was less than 1 and greater than 0. So remember, I tried to tell you before that the a value, we don't care about the negative sign. All we care about is what is the value of a. The negative sign, if there is one for a, that's going to tell us whether it's going to be a reflection of the x-axis. Okay, so that's how that is important. Now, the third bullet, important right here is this equation for axis of symmetry. X is equal to negative b over 2a. Now, that right there is something that you should have remembered or maybe recall from Algebra 1. In Algebra 1, we didn't talk about vertex form and finding the vertex using vertex form. You are just told to find the axis of symmetry, okay? And remember, this is x is equal to negative b over 2a. So where do you get the values for b and a? That's coming from standard form of the function. So once you figure out what x is, in order to figure out your value of y for the vertex, you're going to take that value of x, plug it into the equation, and voila, you will get yourself y. Okay. And then lastly right there, I mentioned it in the beginning, the y-intercept is c, so the point is always going to be 0, c on the parabola. Let's go ahead and move along right here. Now, some of the important things as far as the actual parabola itself is you're going to have to be able to describe where is the parabola decreasing, as you can see right here in this first diagram, and we must also be able to describe where it is increasing. Now, at the vertex, it's neither increasing or decreasing. Okay, so that right there is important to remember. So let's just say, for example, that in this diagram, let's say x is equal to 1. Okay, that's where my axis of symmetry is, where x is equal to 1. So if that's the case, what I'm going to go ahead and say is that my parabola is decreasing when all values of x happen to be less than 1. That is how we will go ahead and notate this. Okay, so right here, let's just say x is equal to 1. That is this axis of symmetry. What I will use to notate the decreasing is that x is going to be all values less than 1. That's where it's decreasing, right? Because it continues to decrease, 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 goes down to the minimum. It increases right here for all values of x that is greater than 1. And then actually at 1, that is the minimum value right here. Some things to once again kind of remember. Domain. Domain actually is your values of x. And for a parabola that's going up or down, your values of x is all real numbers because remember, the parabola is actually going up and out wide. Okay? It could be very narrow, but it's going up and outwards, or it could be very wide or shrinking, vertical shrink, and then it's going up and out. All right, so that is your domain. Your range, however, will be depending on where the minimum and maximum is. So let's say right here, my minimum happens to be at the ordered pair, or my vertex is at 1 comma, let's just say 1. Okay, if I say that the minimum is at 1 1 right here, then my range will be all values greater than or equal to 1. Okay, so you can actually include this point, and everything above the vertex, including the vertex, okay, make sure you include the vertex as well, will be your range. The same thing applies to a parabola that's going downwards. The difference right here is that we have a maximum, right, because it is going downwards. And so hopefully that you could put together pretty easily. And then we will come back to this in the next lesson. So let's go ahead and take a look at number 1, and let's begin to graph this out. Now our function right here happens to be in vertex form. Okay, so hopefully we realize that your vertex is going to be at -1, 0. Remember, this is h, out here is k, but there is no number, so it means it's 0, right? So there's our vertex. So let's go ahead, and I'll go ahead and put the vertex down at -1, 0. So if we think about comparing to the parent function, our parabola has shifted 1 unit to the left. Next up, it says label the vertex and the axis of symmetry. Okay, so now, since this is already in vertex form, I don't need to worry about x is equal to -b over 2a. Remember, the axis of symmetry is a line that's going to go through the vertex. It is an equation of a vertical line. So I'm going to go ahead and put AOS for axis of symmetry. And a lot of times, students will just give me a number. That number is incorrect. You must give me the equation of a line. And that is the axis of symmetry, and this will be x is equal to -1. There is your axis of symmetry. We also have an equation, okay, I guess to help you remember, is x is equal to h. So if we know what h is, then we can go ahead and plug that in, and there's your axis of symmetry. So you could add that to your notes as well, for axis of symmetry, along with x is equal to -b over 2a. I look at my a value next, okay, because now it says find the minimum or maximum value of the function. All right, so my parabola, because my value of a, okay, a is equal to positive, or, okay, if a is positive, then this right here means that we have ourselves a minimum, because the parabola will go upwards. So we're going to try to find the minimum value. Where exactly is the minimum? Okay, it's down right here at 0. Right? It cannot go any higher or lower than 0. In this instance, it can't get any lower than 0 because that's my minimum. So we'll go ahead and put right here minimum is equal to 0. Next up, let's go ahead and graph this out. Remember, this is pretty much your parent function shifted to the left. So we could put -0, 1. I'll go ahead and put 0, 1, -2, -3. If you plug in 0 into the function, you get yourself 0 plus 1 is 1, 1 squared is 1. At -2, you're also at 1 because it's symmetric. You plug in 1, we get 1 plus 1 is 2, 2 squared is 4. So at 1 and 4, -3 and 4. So let's go ahead. We can say that we have intervals of 1 in our graph. Hopefully you realize that based on what I have here. And let's go 0, 1, 1, 4, and we'll put the points directly on the opposite side of our axis of symmetry, because once again it is symmetrical, and that is the beauty of it. Alright, we're almost done right here. The next thing is we got to determine, okay, looking at our function, where is it decreasing and where is it increasing? And I guess the easiest way is always look at your function from left to right. If I look right here, from left to right, it is going downwards. So what I will say right here is this. The function, it decreases all the way down, keep going, keep going, keep going right here to this value of x. That value of x is -1. So we'll say it decreases when x is less than -1. And then it hits the minimum, it makes an upward trend, and so we'll say for the next part, it increases when x is greater than -1. And you must also make sure you notate that. For our domain, we look at our values of x. Remember, it continues infinitely stretching out left and right, so that means that our domain is all real. My range, my values of y. And my values of y right here go no lower than this, at 0. So we'll go ahead and say range is greater than, or y is greater than or equal to 0 right here. All right, so there we have it. We put all parts there for number 1. Let's take a look at number 2. All right, on this equation, it's once again in vertex form. So what we could say first off is the vertex happens to be using these numbers right here, and my vertex is going to be at 4, -5. There's h, there's k. Looking at our value of a right here, more specifically the 2 should tell us that we have ourselves a vertical stretch. The negative in front of the 2 should tell us we have an x-axis reflection. So it is going downwards. So let's go ahead. We labeled the vertex for -5. Let's go ahead right here. Probably better off, let's do intervals of 2. So we have 4, and then we'll go down right there. There's -5. So there's my vertex. So if we want to find the remaining points right here, now on this one, you probably should make a graph or make yourself a table because we're not dealing with the parent function anymore. So I'll go ahead right here. Like I said, might be better off you guys use a separate sheet of paper because you're going to run out of space. So we have x and y. We got 4, -5, and we could go ahead and plug in numbers like 5 and 6, 3 and 2. So let's go ahead and plug 3 in right here. 3 minus 4, -1. I square that, it becomes +1. We multiply that by -2 to get -2, and -2 minus 5 is -7. So right here, when you plug in 3 and 5, you should end up with -7. Next up, when x is 2, so we'll have 2 minus 4, that's -2. Square that, you get 4. Times -2, -8. -8 minus 5, that'll get us -13. So that'll be kind of off the graph right here since our intervals are kind of small. But we have the main ones. We have right here at 3, we're at -7. And then at 5, we're right here at -7 as well. Now when you use graph paper, you should do a better job being able to go put that, draw those points, and put it all together. A little bit more neater than what I've done right here on the tablet. Okay, so there's the basic idea of our function, right? Next up, let's find the axis of symmetry. Remember, axis of symmetry is this vertical line that's going to go through the vertex. So I'll put axis of symmetry, and don't forget it's an equation of a line, so it's x is equal to h, which is 4. Right, so there it is right here, 4. That's why I drew my dotted line there. We have, next up, our maximum, because the graph reaches its height, and the maximum is actually, this time around, it's going to be at -5. There's the max. That's the highest value, right, for our value of y here. We take a look at how this time the function right here is from left to right, it's going upwards. So I'll say right here, our function increases when x is less than, once again, this value of x, which is 4. It decreases right here as x is greater than 4. And then it makes its way back down. Lastly, domain. We have all real. Our range. It's going to be our highest value of y, which is our max. And our range is going to be when y is less than or equal to -5. Because at -5, remember, it's part of the function, it's part of the range, and it's going to go everywhere that is below that, and also at that point. All right, last one. Let's take a look at number 3. On number 3, our function is not in vertex form. It's in standard form. So if I want to start off and find the axis of symmetry, I have to figure out what B and A is. Remember, the axis of symmetry, the equation is x is equal to h, or it's also x is equal to -b over 2a. So right here, my b term is -3. My a term is 3 over 2. So let's go ahead and put -3 over 2 times a, which is 3/2. Make things a little challenging here. But -3, that right there is +3. And then this right here can cancel out, and I'm left with 3 over 3, which equals to 1. Beautiful. Nice and easy. Always love that. But we don't exactly know where our vertex is. In order to find the y value, since I know what x is, we can go ahead and plug this value of 1 into our function and then simplify it out. So let's do that. When I go ahead, I've got 3/2. All right, plug in 1 right here. 1 squared is 1 times 3/2 is 3/2. Minus 3 times 1. Remember, you do need to go from left to right. So 3/2 minus 3 is going to get us -1.5, or -1 1/2. We go ahead and subtract 1 from that. That'll take us to -2.5. So my value of y right here for my vertex, we have our vertex is going to be 1, -2.5. And once again, I've got -2.5 by taking my value of x right here and plugging it into our function. Definitely might be a question that you want to practice using your calculator with. And don't forget, your calculator does not know order of operations. You have to make sure you do that yourself by using parentheses or knowing your order of operations the best you can. So there's my vertex. my axis of symmetry. X is equal to h, which happens to be 1. So we have this all right here. Next up, let's find the remaining points. We have, so at 1, we're at negative 2.5. You could use numbers like 2, 3, 0, negative 1. All right, remember, the net remaining points are found by plugging it into our equation. And just to kind of speed things up right here, if we were in class, I'd have you guys do it yourself. When you plug in 2, you're at negative 1. So when you're at 0, you're also at negative 1. All right, and then when you plug in negative 1, we're at 3.5. And when you plug in at 3, we're at 3.5 as well. So let's plot our points. We're over here at 2, negative 1. That means at 0, we're at negative 1. And then at 3, we're at 3.5. And same over here at the other side at negative 1. Okay. So if you think about things right now, our value of A is 3 over 2, which is the same thing as 1.5. So hopefully if I ask you the question, do we have a vertical stretch or shrink, you should be able to tell me that this is a vertical stretch. Our A value is greater than 1. It's going upwards. There is no negative, so there's no reflection. All right. So we have our vertex, we have our axis of symmetry. Then let's go ahead and finish this off. We have a minimum. So our minimum is going to be at x is, what is it? Or we could just put our value down. We could say minimum at negative 2.5. Right? It doesn't go any lower than that. That's where it's at its lowest. We talk about where does it decrease? It decreases when x is less than 1. Right? It's going downwards. It increases for values of x greater than 1. We have next up our domain, all real. Range right here is going to be all values greater than, so we'll go ahead, all values of y greater than or equal to negative 2.5. And there you have it. We now know every single part, or at least the main parts, of a parabola.